morning and welcome to the Operational Excellence Online Conference, a one-day Industry Week conference for manufacturers. I'm pleased to be the moderator for this session, data-rich but information-poor. My name is Adrienne Selko, and I'm a Senior Editor for Industry Week. This session is sponsored by Apriso. During today's webinar, Ensign Bickford Aerospace and Defense Company will share insights on how to best manage a paperless manufacturing project, including the vendor selection process, establishing basic steps for implementation, what implementation challenges to expect, and how to best measure success. At Industry Week, our mission is to connect manufacturing decision makers to share ideas and tools that inspire action. We strive to provide information that helps you make better decisions to achieve your goals. Today's webinar brings together members of the manufacturing community to discuss strategic and operational issues. To facilitate this discussion, we will have a live audience-driven Q&A session, so please submit your questions throughout the webinar. Our speakers today will address as many questions as they can following the presentation. So as questions occur to you, please type them in the box provided on your computer screen in the lower left-hand corner and hit the Submit button. Wherever possible, we ask that you direct your question to a specific speaker. Before I introduce our speakers, there are a few housekeeping issues I'd like to review. First of all, note the special View My Agenda button on the left side of your console. You can think of this button as your home button. By clicking it, you'll go to the lobby page that shows a list of the other online conference sessions you registered for. It is also the entry point for logging into other sessions. Of course, you can also use the URL provided in your email to reach this same lobby page. This session will be archived, as will all other sessions from the Operational Excellence Online Conference. We encourage you to direct coworkers to the recorded presentation. This presentation will be available for viewing in a few days. You'll be able to view it by using the same URL you used to attend today's event, and you'll also be able to find it on the industryweek.com website in our events area. As you look over your computer screen, you should see buttons that allow you to enlarge the slides and also to download and print the slides. To save the slides directly to your hard drive, if you're using Internet Explorer, right-click the Download Slides button and choose Save Target As. If you're using Firefox as your browser, right-click the Download Slides button and choose Save Link As. About volume control, if you need to adjust the volume, turn your attention to the speaker control located directly below the slide. You may also need to adjust the master volume of your computer system. And at the bottom of the slide in front of you are a couple of additional suggestions that will improve your viewing experience. We ask that you please disable your pop-up blocker so you can receive and respond to the feedback form at the end of the presentation. If for some reason your computer does not advance as the presentation begins, press the F5 button to reload your page and the presentation should advance normally. I'd like to introduce our first two speakers. We have with us today Trevor Hughes, who is the Director of Operations ISD for the Ensign Bickford Aerospace and Defense Company. Trevor brings 20 years of experience in manufacturing operations and since 1998 has brought cross-functional experience as quality engineer, manufacturing engineer, production manager, and background in continuous improvement to Ensign Bickford. Currently is AFD Director of Operations at MBDA's Defense Moore Park, California site. He is focused on improvement armed fire device product lines via lean manufacturing and technology integration. We also have with us Jarek Mundut, who is Manufacturing Systems Lead Engineer for Ensign Bickford. Jared brings 10 years of manufacturing engineering experience from companies including Kodak Remote Sensing Systems, ITT Space Systems Division, and at Ensign he has overseen the manufacturing of many product lines, including the flexible confined detonating cord assembly, the first cell deployment of Apriso's Flexnet. I'd like to turn the call over to Trevor.
Good morning, everyone. I'm Trevor Hughes, Director of Operations for Ensign Bickford Aerospace and Defense Company, and my co-presenter today is going to be Jared McNutt, and he's our Manufacturing Systems Lead Engineer. Today we're going to be talking about the implementation of an MES system in an aerospace environment. All right? We're going to focus today on I'm going to give you a summary here. We're going to focus today on what challenges we had that led to the MES solution that we have, how we chose our provider, and what benefits we realized from that implementation. And then finally, we're going to give you a look at some of the actual solutions we came up with as part of the implementation, sort of like real-life examples of solutions that we're using on our production floor today. Next slide, please. So who are we? We are Ensign Bickford Aerospace and Defense Company, part of Ensign Bickford Industries. We're privately owned, and we were founded in 1836. Our company started out manufacturing black powder fuse way back in the 1800s, and our product lines followed the evolution of technology to where we are today. We have a wide breadth of products ranging from minefield breaching and demolition to crew escape systems on aircraft and spacecraft separation products. And we pride ourselves on well-engineered quality products delivered in a timely fashion. Next slide, please. So what do we manufacture? And I'm not going to go too much into like an extended commercial for Ensign Bickford. Any additional detail you want to know about our products can be found at www.eba-d.com. But what I want to do is run through some of our products we manufacture to give you sort of an idea of the variety of products that we use and what we will be using our MES solution on, and some of the things and one of the products that we are using the MES solution on. The first on the slide that we have in front of us right now is the FCDCA. It's at the top of the page, and that's what we piloted our MES solution on. The FCDCA is used as an explosive transfer line, and it's sort of like an explosive version of an electrical cable. It takes an explosive signal from one side of a spacecraft to the other to initiate events such as fairing openings or stage separation. The other example that we have on these pages are our conical destruct charge, which is used to destroy launch vehicles if it deviates from its trajectory. And the other is a frangible joint, which is used as sort of a zipper to open vehicle fairings and for separating the stages of a rocket. Okay, next slide, please. On the Special Forces and military side, we manufacture a variety of items for the warfighter, the guys with the boots on the ground. So the first product picture here is our rapid wall breaching kit. Say that 3 times fast, right? It's used to gain entry to buildings through reinforced concrete walls and cinder block walls. You simply slap the shaped charge on the wall, hit the initiator, and an entry opening is created for the warfighter. So the next one we have is the breacher strip. This is sort of a finesse version of the last thing we just talked about. And these are strips that have self-adhesive on one side and explosive on the other, and they can be non-electrically initiated by one of our other products, a detonator shock tube assembly, but they're used to gain entry to interior doors and small exterior doors. Next slide, please. So my final example of the products we make are some of our vehicle survivability products. These items are attached to the outside of tanks, armored personnel vehicles, and are designed to protect against RPGs, rocket-propelled grenades, improvised explosives, and anti-personnel rounds. But these products have detailed requirements for capturing how we built them, what they contain, and any results of the testing that we submit them to. Next slide, please. So, with a basic understanding of what we make, I'm going to talk about some of the challenges we faced making those products. So what challenges do we have? We have a variety of products. We have a variety of data requirements on these products. We have a ton of information that our customer wants on these products. We make them for them. So in the case of EBAD, 2 primary issues drove us to make an improvement on the way we were managing production. We really had reached the limitation on what paper could do for us. Everything was on paper routings, data sheets, manufacturing instructions. All those documents required a tremendous amount of resources to manage and to print out. You talk about file cabinets, you talk about the quality engineers having to manage just tons of paperwork. We were there. Manually entry on paper forms was a ton of risk for us because it opens up everything to human error. Incorrectly entered data, lost data sheets, skip manufacturing inspection steps. They're all problems that we had, we were well familiar with, and we identified those as a high priority to fix because to us in the aerospace world, the paperwork is worth as much as the actual product that we're shipping. The second thing that we wanted to solve is we had all this data that we were collecting on the manufacturing floor, but we didn't have it in a usable, coherent product. We were data-rich, information poor, as the saying goes. We had a ton of it, but really was it doing anything for us? We were diligent about capturing it and evaluating at the point of acquisition off of gauges and things within the manufacturing cell, but the opportunity existed to further analyze that data. So we had all the data. Our quality engineers spent a ton of time trying to wade through all of it. We had some control charts, but we really didn't have anything that could manage the floor for us effectively. And that was something we wanted to solve. So what did we want to do here? We also wanted to feed it back to the process owners real time to be able to make the decision on the manufacturing floor real time instead of having to wait until afterwards to actually make that decision. So after we investigated production modules for our ERP system, we determined that they were really not sufficient for our needs, and we needed to go a step further. So we actually started looking at dedicated systems for the operations floor and looking for dedicated systems that will allow us to make that next great leap forward in manufacturing in capability and both effectiveness. And so that solution to us was the manufacturing execution system, or also known as the manufacturing management system. So where we're going from there, we're going to talk about some of our difficulties on what we did on implementing the system and the process by which we made our selection. So how did we go about making the decision on who was going to provide our solution once we knew what a solution, the MES solution was for us? What really mattered to us? So essentially what we did was we assembled a cross-functional team. We had IT personnel, we had quality engineers, manufacturing engineers, producers. We assembled a cross-functional team to evaluate the systems that are out there in the industry. And so we did a number of vendor surveys. We did a number of on-site visits. We actually went through some of the systems real time with the people that were using them. And we did a ton of analysis of the system capabilities and cost analysis because everything has to actually impact the bottom line, obviously. After the initial down select, our finalists were evaluated on how well they met our core system requirements. There's three key areas. It had to be simple. The system needed to be operator-friendly and intuitive. Ease of use would be the major priority, and as I say on the slide, this could make or break the effort. If the system was not easy for the producer to use, they'd fight it all every step of the way. They would actually have more challenges for you than you could actually deal with. So that was one of our highest priorities. We had to be able to make the system very easy to use. Okay, the second one was and the system needed to be proven. We didn't want to get a system that hadn't been used out in the industry, that hadn't been run through the ringer. So we needed to have that system proven and successful in use in other industries with similar manufacturing operations. But we realized with aerospace it wasn't going to be one-to-one. The system also had to be flexible. We had to be able to configure the system for our business processes across many product lines without a ton of code customization. We didn't want to get caught in the trap where every little change that we made had to require a ton of investment and a huge learning curve. It needed to be easily scalable because we have a number of facilities across the nation. We wanted to be able to move the solution from one facility to the other. So at the end of it all, when we looked at all these elements, at the end of our selection process, EBAD determined that the Flexnet system from Apriso was our logical choice. Next slide, please. So why Apriso and the Flexnet system? Simply stated, Apriso and the Flexnet system offered the greatest flexibility and capability. It offered us, quite honestly, more capability than we would probably use. We wanted to have more capability, obviously, than we would need. The platform covered all the bases from incoming materials to control of manufacturing operations. And it brought it all together to work seamlessly, making the system work to our advantage. At the same time, it also allowed us to customize our solution when an out-of-the-box solution was insufficient. We didn't want anything that we wouldn't be able to modify or change to our requirements. So Apriso was there to support us either way, and they were there for us to support us on when we wanted to do it ourselves and or use something out of the box. So that was probably one of the bigger selling points. They really gave us the flexibility to do that. Next slide, please. So once we had Apriso on board, how do we kick off our implementation? So instead of choosing an easy cell to start with, which most people would think, we picked the most difficult production cell we had. And the reason for that was this. We figured if we ran a pilot on the most difficult cell we had, then that pilot would be easily modifiable and we'd be able to roll that out across the company in an easier fashion. So we heavy loaded the front schedule of the implementation up front in order to gain the rewards later. So we actually chose one of our FCDC lines, and it was chosen because it was mature, process was in control, we knew what to expect with it. It had a ton of heavy data requirements. It had multiple methods of inspection, and it possessed many manual, semi-automated, and fully automated operations. This is not a single operation manufacturing process. This is a manufacturing process that had a ton of variety throughout the whole manufacturing process. So what did we do after we actually had the FCDC cell up and running for the pilot? Next slide, please. Okay, for our challenges that we had on the pilot cell, there was an appreciable learning curve on implementing the system. One of the first things we realized very quickly, this is going to require a significant amount of resources to accomplish. We couldn't put a single engineer on this project. This is going to require a cross-functional team with many hours to actually to implement. And the reason for that is flexibility does have a price. We need to be flexible and customizable. We wanted to be able to handle a lot of things internally, but in order to do that, we had to learn the Flexnet and the system ourselves. We had to internally develop programming experts so we wouldn't be dependent upon the vendor. And the reason why we didn't want to be dependent upon the vendor will be discussed later, but we had kind of an interesting experience with our ERP system, and which was very inflexible, and so we kind of reacted the other way and said, hey, with this system we want to be able to do everything ourselves so we're not held hostage to a vendor. So anyway, but that flexibility does have a price. The gauge and equipment integration was found to be challenging in some cases. We're doing machine integration. Some of the systems that we put in place in measuring data and pulling data out of machines, it was simple for RS-232. It was challenging for analog data, and we had to do some custom screens for that. And then we had to actually put some custom programming from the team on machine integration as well. The next item was integration with our ERP system was not seamless. Anytime you communicate between two different systems, it's going to require significant work. Our IT personnel really spent a ton of time on our ERP system upgrades that didn't work well with the system. And to this day, they're still heavily involved in the system itself. So that leads into the last one. Heavy IT support was required. The effort required a full-time IT professional. Several other part-time IT personnel were in support, making screens, resolving small issues. And then the last thing was hardware requirements were underestimated. Computers out on the floor, servers, things of that nature. I think we underestimated the impact of that. Next slide, please. Okay, so with all that said, what were some of the advantages realized by our implementation? When we looked at the cost savings for the systems, the projected financial savings weren't obvious at the time we made the decision. There are a ton of knowns out there. Developing a return on investment projection, it was very difficult. Fortunately, we have a management crew here that saw the advantages of the system, and some of the intangibles that we found more than outweighed the uncertainty on the return on investment. So we had a hard time putting a price tag on things such as lot acceptance testing, failure avoidance, cost or poor quality. How would the system impact the numbers? We had a hard time putting a price tag on that. But after system implementation, it looked like we had less than a 5% direct labor cost savings, and that's just direct labor costs. That's the person out on the floor. How much money did we save directly on the person on the floor over a paper-based system? They're still interfacing with either paper-based or computer, so it really wasn't that much of a difference. However, on the other side of the process, we realized a ton of return in actual time savings, printing out paper management, scanning things into the system, managing data, things of that nature. That's really where we had our return on investment. But the biggest thing that we had was a tremendous expansion in data collection and processing, visual feedback, and mistake proofing. And I'd like the next slide, please. So with that said, I'm going to turn the presentation over to Jared McNutt, our manufacturing systems lead engineer, and he's going to go through some of the specific solutions that we came up with and some of the advantages. So I'm going to turn that over to Jared now.
So I'm going to start from the beginning of the process. Any manufacturing process, the process starts from the material. So as far as material tracking, we use barcoding at the component level and at the assembly level. At the component level, we have barcodes that are printed on our lot acceptance tags from our ERP system. As for the assembly, we send the barcode information, which is linked from our ERP system to Flexnet, to a Zebra printer during the first operation for every serial on a shop order or work order. So the part number and the serial number are printed right from Flexnet to a printer, and we attach that to our part. We transfer the material from our warehouse to a specific floor location in our ERP system. As the material is issued to the assembly in Flexnet, a transaction is sent, and the inventory quantity is instantly decremented from our ERP system. And likewise, as more material is transferred to this floor location, a transaction is sent to Flexnet, and the user has the ability to see in Flexnet how much quantity of a lot is available. So at any time, the shop floor supervisor can look into our system in Flexnet and see what quantity is available. Before we run out, he can issue material to the floor just to keep things moving along. Next slide, please. So this is a typical material issuance screen, which first appears after the operator scans the serial into an operation that requires material. We allow the system to auto-populate the last component lot used per work order, so the operator doesn't have to scan it in each time for every component. Once a lot quantity for a component is depleted, the operator is displayed with an error message right on the screen, and an email notification is also sent to the team indicating that more material is required. We also track the material expiration in Flexnet, which the date is sent over from our ERP system. So this makes it nice, there's no more operators on the floor waiting for material, running around trying to find someone who can get that material out for them. It's instant, and this really is sped up our process because material tracking and getting material out of warehouses is in some cases time-consuming. So we have experienced a great advantage now having these errors and emails being sent out. Next slide, please. So once the material is issued, this is a typical operation screen for the user. In this particular screen, the data is sent from a drop gauge to Flexnet, and you can see the value in the value box there. The operator must also enter the gauge number and calibration date, which is printed and attached to the gauge that's being used, and that also is scanned into the gauge box. If the gauge is not entered and or has expired, or if the gauge is of the incorrect precision, an error message is also sent. Actually, we display to the operator, so they can say, "Hey, I got to get this gauge reinspected," or "Oops, I'm using the wrong gauge." So our system allows us to track our gauges and track that this gauge is the right one that's being used. We also, from this particular and all of our operation screens, give the operator the ability to retrieve the documents relative to the operation. So we're able to link which document is relative to which operation step. And we keep these documents as control documents in our ERP system, and that's where we actually go and retrieve them from. The operator also has the ability to initiate their own MRBs or nonconformances, which we feel gives them the empowerment to document their own findings. It's a lot easier. Someone's not walking by, they can't tell them what they're seeing. They can actually say, hey, this isn't typical at this operation. This isn't a defect at this operation, but they found something that's out of the norm. They can generate the MRB, input their findings, and email will be sent to the team letting them know what's going on. And in addition, we also have a help request button. So at any time the operator needs help, they can press the Request Help button, and this sends an email to the team notifying them of the help request. Next slide. So this here is what we call our shop order status screen. Here, anyone, the quality engineer, quality inspector, upper management, manufacturing engineers can go to this screen and go to a specific shop order or a specific group of shop orders, and they can look at details relative to that. They have the ability to see how many serials and what serials have completed a particular operation, the material lot used, the quantities of inventory available on the floor, and any data that has been collected. Next slide, please. So within the shop order status screen, like I said, the team has the ability to also monitor operator times versus the standard times that they have created for the manufacturing cell. We color code the times. Green indicates the fastest time per operation per work order, and the red indicates the slowest. This allows us to determine what may have slowed the operator and try to fix it. It also allows us to look at trends and see which operation may need the most attention, because we can track, if this operation, the standard time says it should take 1 minute, the operator's taking 2 minutes for every serial, we can look at that trend. And we can also look from shop order to shop order. Maybe a particular part configuration has something that makes it a little more difficult, and we can focus our attention on that. And it also helps our supervisors to plan the workflow better by providing the details of quantity complete. They can see, okay, this shop order is almost completed. It's at the last operation. Now it's time for me to cut the next shop order. Next slide. So as far as dashboarding and how we are going to display that to the team, we implemented a digital dashboard. And this dashboard is a large, flat, touchscreen TV, which is located right in the manufacturing floor and right in the cell. And it gives any passerby an overview of how the cell is performing. As inspections and non-conformances are gathered, this dashboard is instantly updated, and we apply to refresh rates, which can be changed. And in this particular case, we have the refresh rate set at 180 seconds. And they also have the ability to look at data over a time range. We default it for a week, so every 7 days. That's the start and end day. It's 7 days, but they can look back. They can look at just 1 day. They can go back a month, a year, and see how the data is trending. Next slide. We've also made the graphs interactive. In this particular case, on this slide, if you look at the pie chart, and if the green portion of the pie chart is pressed, our large touch screen is it's a touch screen. The user is displayed with all the serials and the details relative to that defect. So the visual board has also been great in that the producers see real time how the cell is performing, rather than hearing about it weeks later and the manufacturing team questioning to them, what may have happened during that week that you had all these defects. We can track it, see it daily basis. It just allows us to really focus at any given time on trends. And it also allows the operator to provide us critical information as to why these defects should be created. They can say, today you had this many defects. The manufacturing team wasn't actually out on the floor, but they realized that there was a problem, and the operators, you can address it that specific day. Next slide. So we can dig even deeper into our charts. We display to the user run charts for each inspection characteristic. When the run chart is selected, and this is again from our digital dashboard, the user is displayed with a control chart. So when the run chart is selected, you can actually go to our control charts. And each of these points of the run chart can be selected, and the serial number and the data is displayed. So again, that gives us, this particular point is out of control, upper or lower. You can select that point, and you can go and see the serial and the shop order and all the information relative to that serial. Next slide. So from mistake-proofing aspects, what has Flexnet done for us? All the inspection characteristics we capture are done through automation, so that there's no longer fat-fingering entries by the operator. We also embed into our work instructions GSI and CSI steps. So the operator can no longer move forward until these inspections are completed. So if the operator happens to just walk up to the computer, scans the part in, they'll be displayed with an error saying you don't have the correct permission to perform this step. So it prevents that serial from moving on and skipping over an inspection step. Upon receipt of a failure, the system automatically generates an MRB. A notification is sent to the team, and that particular serial, again, cannot move forward until it's dispositioned, whether it's dispositioned, no test, scrapped, whatnot. So it not only prevents from skipping GSI, CSI points, but it also prevents the part from moving on when a defect has been created. So we can use a defect record also to determine if a certain operator is causing all the defects and review the operation to see what interaction may be causing this. We also control in Flexnet which operators have the ability to work on which operation in the event an operator is disqualified. So if we do see the trend that one particular operator is having all these defects and we determine that it's not a process issue, we can assign, we can prevent them to have the ability to work on that operation. Next slide. Along with the MRB creation, we provide the ability within the system to allow an authorized team member to enter rework instructions for an operation. So once an MRB is created and it has been determined and dispositioned as rework, the rework instructions can be put into the system. Any additional material required to perform the rework can also be entered. And a GSI CSI person can also review the rework and instantly approve through the screen. So no longer, if we decide there's rework, we have to go back to your desk, create rework instructions, print it off, get it out to the floor. It's instant. You can do the rework at the point of the rework operation. Next slide. So we also have a machine setup screen that prevents the user from starting an operation prior to the setup being completed. In this example here, we have a press setup dwell time and a press setup pressure that must be entered every morning, and as well as the gauge. So this ensures that the machines are set up properly each day and provides the crucial ability to look at data for any trends. So we can look at the data that was entered and look to see how the machines are performing over time, and we can see who was performing the setups and the gauges that were entered. So it provides us flexibility and to see the data over any period of time, to look at trends at the machine level as well, instead of just the part level. Next slide. So most all of our operations require data entry, and they are collected through the machine integrator functionality that Flexnet provides. In these instances, we control which program and parameters are sent to the machine based on our part configuration, which eliminates the user selection of which program that needs to be run. So based on our data from our ERP system, we're able to code which program needs to be sent to Flexnet and eliminates the user interaction there. Next slide. So one instance of the type of machine we use is an automated cord cutter. Based on the length of the parts coming from our ERP system, all of our shop orders, we may have one big order, but we may have 100 different part configurations, and each one has a different length. So we get that length from our ERP system, which is then sent to Flexnet, and then we send Flexnet sends the correct slow down and stop parameters to the controller. So we slow the machine down at a certain length, and we also stop the machine when it's ready to be cut, and all that is automated now. And because of this confidence level, we haven't had any failures caused by misentry from the user. We have able to move the length inspection, which happened at the very first operation. We were able to move this to the very end of the manufacturing process. So it allows us to get a better one-piece flow. Next slide. Another example is a Sherlock vision system. We have two of these vision systems in operation at two different operations, and we communicate to Flexnet through a visual basic interface. Again, the correct configuration data is sent to the machine, and upon completion, we're able to use Flexnet to validate the acceptance of the parts. So based on the part configuration, the parameters may change, and Flexnet knows that because of how we coded it. Next slide. And I'm going to hand it back to Trevor.
All right, so with all that said, how well do we think that the Apriso Flexnet system, how do we think that that was successful for us? And we consider it very successful. It was a pilot, yes. We tried it out on our hardest line. We learned a lot of lessons. But let's talk about some of the things that we actually were able to realize from the implementation. Our issue that we wanted to address was we had reached the limitation of what paper could do for us. And we think we resolved that because the new system eliminates paper altogether, but it allows us a little bit of flexibility. Some of our customers require custom paper reports and things of that nature, hard reports. We're able to do that out of the system as well, but it eliminated a lot of our paper issues. The data entry errors and skip steps were prevented. They are prevented, and we're able to realize the benefits associated with that. The second issue that we had was we had the data. We didn't have any usable coherent product. So the beginning of this whole presentation, we talked about being data rich and information poor. So now we think we're information rich. We're able to utilize that information and react to it real time. We have no more delays. We're able to pull a lot more information to a usable content that we were able to do before. So we talk about data analysis is conducted instantaneously by the system and presented to the user. The producers see this information and are able to react to it. That's huge for us. And then feeding that information back to the process owners and management through dashboarding. We do dashboarding not only out on the floor but remotely from management computers. It allows management to get a real-time grasp on our production situation and some of the issues that we have. The third one, simple operation. Our operators and inspectors, they actually started out with very resistant to change. You know, they're used to the old paperwork method, but they now prefer the new system over the old way of conducting business through paper. Paper can get lost. The system, you know, the computer's right in front of them now. The system allows them to prevent mistakes. Everyone's human, so everyone makes mistakes from time to time, and the system prevents them from making mistakes. So that's big to them to know that they've got a belt and suspenders kind of situation going, to where if they don't catch it, you know, the system's going to catch it for them, which is really great for us for mistake proofing. And then we use barcoding all over the place, so it makes it easier to interface with the system. We barcode our documents. We barcode pretty much everything, parts out on the floor. So it's easy to scan. The operator doesn't have to write down numbers anymore. So it's an easy system to interface with. Okay, proven use with the Apriso system. There's extensive use of the system in the industry, and more companies, and I'm sure Rick is going to talk about this. There's more and more companies added to the list of users every year. Apriso has a summit that they have, and it was really refreshing to see the variety of users that are out there with the system, and we're able to gain information from each other and share information, and that's huge for us as well. And then support for the system has been outstanding from our customers. Our customers love the system. Any kind of system that, such as the Apriso system, that allows us to eliminate mistakes, give them the data that they need, prevent, fat finger mistakes. They're really excited about that. And one of the benefits that we see from them is much more confidence more confidence in our product, more confidence in the data behind the product, and they allow us a little bit more leeway, knowing that we have a bulletproof system behind it. And then finally, the flexibility and ease of configuration. The system is very flexible, and configuration is managed internally. We're not dependent upon outside programmers. Now, there's two ways you can go about it, but we made the decision to be more self-sufficient than other businesses may want to be. But we're able to do that, and it's very easy for us to manage that. And that's one of the benefits is the system is SQL-based, and the language is used throughout the industry. There's no custom code here. This is all code that's in computer language that is used in the industry right now. So with all that being said, we've considered the implementation very successful. The FCDC cell was our first pilot cell. We're in the midst right now of rolling that out to a number of our products, and we're very confident about our ability to make it successful. And that's about the presentation that I have. So I'm going to turn it back over to Adrian now. Adrian?
Thanks. I'd like to introduce our next speaker, Rick Galiso, who is Aerospace and Defense and Life Sciences Industry Director for Apriso. Rick has over 22 years of experience in technology and services businesses within highly regulated markets. He leads Apriso's industry practice aimed at technology transfer, paperless production, quality assurance, manufacturing efficiencies, and track and trace solutions. We'd like to welcome Rick.
Thank you, Adrian, and especially to Trevor and Jared from Ensign Bigford for sharing their approach to driving data, paper data, into executable information, digitized information. I wanted to take the next 10 minutes or so to highlight some unique challenges found in the aerospace and defense industry and to share a few other customer approaches in managing their complexities. Next slide. Not unlike many industries, aerospace and defense have complexities involving mergers, acquisitions, clearly joint ventures, a very large tiered supplier ecosystem, oftentimes driven at a program, not even a company level, but program level, and of course, a truly vigorous web of regulatory guidelines and mandates. Next slide, please. Here's a graphical representation of the industry where a relatively small number of very large corporations are the proverbial tip of the iceberg. Today's prime contractors are also today's subcontractors and vice versa, depending on the programs. Yet what's startling is the sheer number of suppliers really depict the complexities in managing quality with a large number of engineering changes in their products, or a very prevalent engineer-to-order business model, while adhering to regulations, managing complex supply chains, in a timely and efficient fashion, and right now the emergence of the threat of counterfeit in these complex supply chains. Next slide, please. Gartner again this year posted their aerospace and defense supply chain top 25. This is really an excellent insight of those that truly excel, yet the complexities have them continuing to have much more to do. This year, there were about a half dozen key capabilities that Gartner noted that would be impacting supply chains that are taking place this year and over the following few years ahead of us. And I'd like to go through some of those. So the first is essentially the changing technology, volume and mixes continually change. And with it, there's an essential requirement for companies to continually balance and align to these net new normals, their new operating paradigms. The second point is JV, alliances, acquisitions really are essential to be price competitive. Certainly to gain access to other markets and to expand cost-effective life cycle support for performance-based logistics, both in defense and commercial markets. Third finding is ITAR in the U.S. and comparable programs in other countries are difficult enough to manage, but as mentioned earlier, the counterfeit components of the supply chain are really an expanding threat to product integrity. Next point down, aerospace and defense, by and large, run either program-based or business division-based, which as the workforce ages, which is just a fact of the industry, it really exacerbates the difficulty for them to capture and disseminate knowledge from that workforce. Their fifth point was there's a lot of capability in the industry, an awful lot of talent, but just because you can make it doesn't mean it's the optimal way to serve your customers. So there really is a build versus make assessment that's key to the changes in supply chain, what you make, what you outsource, what you partner. And lastly, something that's not often equated to aerospace and defense is sustainability. There's ample proof in other industries that conscious effort yields both direct financial savings and indirect goodwill that overall really benefits both the ecology as well as the economies of corporations in the aerospace and defense industry. Next slide, please. So there are a lot of technologies supporting the A&D industry business activities, but when it comes to manufacturing supply chains, innovative companies are moving away from paper just as quickly as feasible and are largely managing their business with enterprise resource management, product life cycle management, and manufacturing operations management platforms, and to the greatest extent possible, making them as seamlessly integrated as they can. So the industry strategy is largely on a continuum of adoption and proliferation across their operations, but the trend is very strong towards adopting these available technologies to the greatest extent possible. Next slide, please. So Apriso serves the aerospace and defense industry as well as other regulated industries. We offer manufacturers a global platform to create, manage, and continuously improve manufacturing business processes, both across multiple programs and multiple sites. This capability can improve agility, reduce costs, and elevate operational performance, both within a manufacturer's four walls of a particular site, but more importantly, throughout their respective tiered supply networks. Our flagship platform, Flexnet, has been deployed in different manufacturing models with some of the customers that you see noted here. And in addition to Ensign Bickford's overview, I'd like to take the next few minutes to provide some insight on two additional Apriso customers. Next slide, please. So Bombardier's aerospace group is a #1 regional aircraft maker and a leading maker of business jets. Most of the audience listening here today have flown in Bombardier's aircraft, and I can tell you they have very aggressive strategies to assure that more of you in the world's population is transported in their highly efficient C, CRJ, and Q series aircraft, typically in the range of 100 to 145 seat capacity aircraft. Next slide, please. So Bombardier is an engineering and asset-intensive business. To say that it's competitive is an understatement. However, they have a very clear vision of how to leverage a three-platform architecture to design, build, and support their new generation aircraft. They have standardized on ERP, SAP in this case, Dassault PLM, and Apriso in manufacturing operations. Next slide, please. Bombardier wanted to assure alignment to business objectives and support to their partners from a global manufacturing operations solution. In order to efficiently align to their corporate IT structures, they assembled a center of excellence that was chartered with defining and managing the design, the build, and the support for the Flexnet platform. And in doing so, what they've created is an organization that not only implements the Apriso solution, but for the business, they create and manage a governance model for current and emerging business requirements, which really ensures management of their operational best practices across sites and the leverageability of their IT structure at a highly cost-effective position. Next slide, please. So let's take a look at the specific reasons for investing in manufacturing operations management. Their underlying philosophy is very simple, very direct, and I think very concise. It's what gets measured gets done. They wanted to target paper-based inefficiencies. In this case, they targeted 80% as a goal, as an initial goal, I should say. Reduction of cycle times and information collection for ongoing analysis. Also critical to their objectives was capturing valuable intellectual property found in their workforce to manage standard practices and ultimately assure consistency and quality and flexibility to their customers' changing requirements, as it certainly is not a static aspect of the industry. Next slide, please. This is a bit of a busy slide that points out some specific business requirements around supporting their C-Series aircraft lines. And I won't take the time to go into each of them in detail, but some that jump off are paperless, electronic as-built, just-in-time, lean concepts, and closed planning were all key criteria for their success. And we're fortunate enough to be in a position to be helping them on all of those fronts. Next slide, please. Across their paperless real-time factory, if had to kind of condense what this graphic depicts, you can see, what their purpose was and the benefits associated with the Flexnet application as they have implemented it. I really had to net it out. Really, it's us providing paperless real-time manufacturing visualization, control, and synchronization across their manufacturing operations. We just went live in their Maribel facility earlier this month, and that particular go-live consisted of order dispatch, production and quality execution, which had, as you would expect, serial genealogy, tool genealogy, capturing of quality characteristics, first article inspection, key for their business, issue management, a whole litany of reporting, as well as labor tracking. So our partnership overall between Bombardier and Apriso encompasses multiple sites, and we're in the midst of the rollouts now. And those sites, there's sites in Montreal and Belfast, Ireland, Mexico, and Kansas. So overall, pretty exciting partnership that we have with them, and look forward to flying their C-Series in the near future. Next slide, please. In contrast with aircraft that fly, I wanted to talk about MBDA. This is a company that makes systems that arm defense agencies, which are then sometimes deployed in making aircraft and other threats stop flying, frankly put. So MBDA is not a household name, but is a highly respected European consortium that manufactures missiles and missile systems for over 90 armed forces worldwide. Similar to Ensign Bigford and Bombardier, they needed to eliminate paper systems while tightly coupling design to manufacturing in order to manage a large number of engineering change orders. Flexnet is designed for use by process engineers with flexible routing steps from libraries, rework and sequence changes that are easily accommodated, which is really important to them, all in a mostly paperless environment, not entirely, but mostly. And that's largely accomplished by having tight integration to their existing ERP and PLM solution. Again, a common thread there between themselves and Bombardier. So ultimately, this provides visibility from as designed to as worked across components and processes with full traceability and genealogy. We're currently installed in France and Italy. Next slide, please. There's no greater accolade that a solution provider can receive than their own customers talking on their behalf. Ensign Bigford's management team talking today, Bombardier speaking at recent events, and MBDA's quotes here are greatly appreciated. And for the audience, have a few key points that are common, despite the fact that these are entirely different A&D businesses with different product solutions and customer sets. Next slide, please. Summarizing, each had a common goal of driving paper out of manufacturing to gain visibility, improve efficiencies, reduce manual errors, and build quality assurance into processes and not just test for quality irregularities. Next slide, please. But ultimately, in each of these examples and many others in the industry, the goal is to digitize what is commonly being touted now as large data into usable information. That is a journey across very intricate technological designs and complex tiered supply chains. However, the mining of this newly and readily available information is where really large strides and efficiencies will be made. So conceptually, it sounds simple. In practice, there are an awful lot of moving parts, and it's very complex. Apriso continues to expand our already impressive global capabilities with solutions like manufacturing process intelligence and global traceability and genealogy, which build on the core Flexnet platform. At this point, I'd like to turn it back over to Adrian. I thank you for your time today and hope the discussion was valuable.
Okay, great. Thank you very much. Before we get to the Q&A, I just want to ask our audience to please take a few moments to fill out our feedback form. We ask that you please disable your pop-up blockers so you can receive this form. First question, how does your customer interface with MES?
Our customers have the ability to do all the data mining from one of our PCs with Flexnet installed right on the floor. This allows them to focus on asking direct questions relative to specific data, and we're able to give them direct answers since all the data is clearly visible in the system. There's no more digging through piles and piles of paperwork in search of the answer for the customer, or having to do re-inspections or scrapping of parts because data items were missed. So it's really streamlines their use of the system and how they do their final inspections.
Thank you. Next question. How much time do you think you save with customer source inspections?
It varies depending on the order size. But in general, source inspections could have been on site for 3 to 5 days reviewing data once the order was complete. And even in some cases, during those 3 to 5 days, we were still pulling data together from them just because it was spread out over the facility. Now that the data, it's reviewed in as little as 1 day, if not less than 1 day. Flexnet has also put confidence into our customers, and in some instances they have waived certain criteria based on the repeatability of the system, making it easier to move parts from one operation to the next without having the source inspection curtains.
Okay, the next question is, have you seen an impact to your ability to obtain additional work due to the implementation of MES?
All right, that is a very good question, and the answer to that is it certainly has. With our FCDC pilot cell in Simsbury, Connecticut, that cell has become a highlight of our customer tours of the facility. The Flexnet system just running flawlessly in that cell, and with all the data screens up, and our Haas automated machine running, and it's one of the things that attracts our customers when they're on the tours. You know, most of the tour is somewhat blah, and they get to that cell, and it's like, wow, here's something we haven't seen before, and it's something amazing. And it's a showcase for our new production technologies. And I guess to say that it inspires confidence in what we're doing and our plans for the future, that's an understatement. And then one of our customers, which we have in Simsbury, actually we're shared here in Moore Park, California, with our other facility, which makes a different product. And they actually brought in a new product for us in our Moore Park facility based upon what they had seen in Simsbury, Connecticut, and the Flexnet system running in our FCDC cell. And it's just based upon that increased confidence level from the customer saying, hey, you know, I know you guys are are on the ball. You've got great plans for the future. We love what you're doing, and we want to give you new business. So they requested to have the Flexnet system on that product line that they offered us in Moore Park, California. And they even offered us additional business if we could extend that implementation to other parts of their product line. So, yes, certainly it has definitely gained additional work for us.
Okay, thank you. Next question, how does Flexnet interface with your ERP system, and what problems have you seen?
So there are mappings that are created that directs where the data goes and comes from. The data is sent to and fro using XML files. Most of the issues that have occurred have been processing issues relative to the timing of transactions and not necessarily a function of a Flexnet error. An example would be that a lot of material that was entered for a part in Flexnet, and while that part was being worked on, someone manually decremented the quantity from our ERP system, leaving zero quantity available to complete the operation. So we do get an error, but that error it's simple to identify and simple to resolve.
Okay, next question. Can you give some insight on how your decision to manage your own implementation versus outsourcing? We're considering doing the same, but see pros and cons. Knowing what you didn't before, would you still do the same? And any lessons you'd like to share?
Well, that's a good one. Our decision to implement on our own came about from some of our experience with the implementation of our ERP, MRP system. So essentially, when we implemented a system that had been used commercially, but we were the first implementers from the aerospace side. So we really had a difficult time adapting the system to our customer requirements. We were pathfinders. We were the guinea pig, so to speak. So for every change and modification we need to make, we had to go back to the provider and request, system solutions. It took time and money. There's many, many issues that we went through because there's a lot of things in commercial that don't translate easily over to aerospace. So when we had that experience with our ERP system, we were a little gun-shy. So when we looked at our MES system, we wanted to avoid that same situation. And so we put a high priority on home-growing our solution. And that took a lot of time and money. But we thought it was valuable to do for ourselves because it would allow us a little bit more flexibility. So we put a high priority on it. It took, however, there's a price to be paid. It took a lot more time than a typical implementation. We invested heavily in our training our own people at a significant cost. Now we're well positioned to customize the system on the fly, but it took a lot to get there. So for future implementers, I'd say that if you have a line that needs a quick implementation and you don't project many changes, it's pretty stable, it's easier and more cost-effective to have Apriso handle the whole Flexnet solution. In our case, we had a ton of custom needs, and I'd say this to other people. If you have a ton of custom needs and you have a variety of different product lines and types, it may be worth your while to try to grow that internal capability.
Okay, great. Thanks. Unfortunately, we've run out of time. I want to thank Trevor, Jared, and Rick for an excellent presentation today. And I want to remind our audience that a recording of this session and all other online conference sessions will be available on the industryweek.com website. Our next session is about to begin. It's entitled Achieving Improved Profitability Through Waste Reduction. To attend, click the View My Agenda button on the left side of your console. This button will take you back to Lobby, where you can see a list of all the upcoming sessions and a link to log in. We hope you will attend additional operational excellence sessions. I want to thank you for your attendance, and have a great day. Bye.